Hi students, welcome to the session. I am Dr.K.Varada Rajkumar, Associate Professor, Department of CSE-AIML, MLR Institute of Technology, Hyderabad. In this session, we learn about linear search algorithm. Overview of the session. So first we are going to see introduction to linear search. So after that we discuss linear search algorithm and we discuss about time complexity, and finally we discuss about advantages and disadvantages of linear search. Outcome of this lecture, at the end of this lecture you all are apply linear search algorithm to search an element in a collection. So what is linear search? So what is search? Search means we are going to find a particular element in a list. So that is the meaning of search. So what is search? So searching is nothing but finding an element in a list. So linear search means, so linear search is also known as sequential search, is a simple searching algorithm that sequentially checks each element in a collection until a match is found or the entire collection has been examined. Linear search means searching the elements one by one is known as linear search or sequential search. For example, so this is the array A. So this array contains 5 elements. So let us assume these are the 5 elements. So 10, 15, 5, 18, 9. Okay. So now, so linear search means in this list, I am going to find a particular element. So let us assume the searching element equals to 18. So now this searching element is compared with 10, first element. It is not found, then I compare the searching element with the next element, that is 15. So after this I compare 18 with 5. Now 18 we compare with 18. Now we display the message element found. Now if the searching element is 180, now in this case 180 equals to 18? No. Then move to last number. 180 equals to 9? No. It is false. So here in this case we reach end of the list, end of the array. So we display not found. Okay. So this is simple linear search. So linear search is also known as sequential search, is a simple searching algorithm that sequentially checks each element in a collection until a match is found or the entire collection has been examined. In this case, when we search for 18 is found at index 3. These are the indexes 0, 1, 2, 3, 4. 18 is found at index 3. So now we see algorithm. So for linear search, the input is array and the searching element. The searching element is target element. And output is, this linear search will return index of the target element in the list if found, or flag indicating that the element is not present. If the element not present in the list, then that we know with the help of a flag. Okay. So here the algorithm is simple. Starting at the beginning of the list, that is index 0. Now compare the target element with the element at the current index, and if they match, return current index as the position of the target element. The search is complete now. Otherwise, move to the next element in the list, that is increment the index by 1. Repeat steps 2 to 4 until you either find the target element or reach the end of the list. If you reach the end of the list without finding the target element, return a flag indicating that the element is not present in the list. Okay, so let us assume, So this is the array A. So let us assume there are 6 elements present in the list. Now what are the indexes? 0, 1, 2, 3, 4, 5. Let us assume these are the numbers 15, 18, 5, 29, 34, 26. Let us assume the target is 29. Now what is the algorithm? Start at the beginning of the list, index 0. Now I compare target with A of 0. Now compare. So what is the target? 29 equals to A of 0, 15. No, not found. Then increment the index by 1. Now what is the index? 0. Now this is incremented by 1. Now the index is 1. Now what is A of 1? 18. In next iteration we compare target element with 18. Not found. Then again increment index A of 2. Now what is A of 2? 5. Now not found. Again increment index. Now what is index? 2. Now it is 3. What is A of 3? 29. So 29 equals to 29. True. So return the current index at the position of the target element. Here the target element 29. So 29 index is 3 now. Now so this function will return 3. If the searching element is 129. Now in this case, so 129 is not matched with the 29. So we move to next one, 34. 129 equals to 34. No. Then again increment the I value. Now index will be 5. Now you check 129 equals to 26. False. Now in this case we reach the end of the list. So we return some flag value, maybe -1. Okay. Now if we return -1, then we assume that element not found in the list. If we return any index, then the element found in the list. Okay, this is the linear search algorithm. So coming to time complexity of linear search. Let us assume, so these are the numbers. So 10, 20, 18, 5. Now what is the best case time complexity? Best case means if the searching element equals to 10. That means in first comparison only we found the element. Now this case we called as best time complexity. Now what is average case time complexity? For example, I am searching for 18. Now how many comparisons? 3 comparisons. So 18 equals to 10 is first comparison. Second, 20 equals to 18, second comparison. So third, 18 equals to 18. Now it is successful. Now element found. So this case we called as average case. Okay. So worst case means either we check all the elements, or if maybe the element not found. So this is the worst case. Here in this case, if you search for 5, that is the worst case, or you search for an element 15, that is also worst case. Okay. Now in best case we can compare only one time. So the best case time complexity is big O of 1 here. The best case occurs when the target element is found at the beginning of the list. Here so 10 is beginning of the list. In this scenario only one comparison is needed to locate the element. So average case time complexity is big O of n. On average, linear search has to examine half of the list, which means roughly n by 2 comparisons are made in the process. So the time complexity is big O of n for average case also. So worst case time complexity is big O of n. The worst case scenario occurs when the target element is either at the end of the list or not in the list at all. In this case, linear search needs to examine all elements, all n elements. Okay, in this case, if the searching element is 5, then we can search all the n elements, those are 4. If the element is not found, in this case also we are going to compare 4 times. So these two are the worst case time complexities. So what is the best case time complexity? So big O of 1. What is average case time complexity? Big O of n. So what is worst case time complexity? Big O of n for linear search. So coming to advantages of linear search, first one is it is simple. It is simple to implement. The algorithm is very simple. Second advantage is easy of implementation. Easily we can implement. Third one, low space complexity. We don't need any extra space and suitable for small data sets. Okay, these are the advantages of linear search. So coming to disadvantages, one is high time complexity. So high time complexity, if the elements are 10 or 15, then it is very easy to compare. If the data set is huge, if you compare 1 lakh numbers, then it takes huge time. And inefficiency for large data sets and lack of optimization and limited real world use. Okay, here we can apply this linear search on limited data set only. In real time we have huge data set. So linear search is limited to real world use and lack of optimization. So the time complexity is high and it was not efficient for large data sets. Summary of the session. In this session we learned about linear search algorithm. So linear search is a simple algorithm. It is suitable for small data sets. And here the disadvantage is inefficiency for large data sets. Okay. In next class, we will learn about implementation of linear search in C programming. If you have any doubts, so place your doubts in the comment section. I will answer all your doubts. Thank you.